This is Chapter 11, Problem 23. Strictly speaking, this is a chemistry problem, but since it's really just a math problem disguised as a chemistry problem, I thought I would take it on here. So we have here Poiseuille's law. The flow rate is the change in pressure, or the pressure applied by a pump, times pi times the radius of the pipe to the fourth, divided by 8 times the length times the viscosity of the solution, eta. And the question is, which graph depicts the rate of energy consumed over time in order to maintain constant flow through a pipe subject to Boiler scale? Well, I'm not going to copy all the graphs here. You're going to have to take a look at them yourself. But basically, energy, if you look at energy versus time, right? And they're not looking for a quantitative answer here. They're looking for a qualitative answer. Energy over time, one of them is a constant decrease in energy, one is a constant increase in energy, one grows exponentially early and becomes asymptotic, and the other grows exponentially with time. All right, so which one is the actual shape of the curve you would expect? Well, what happens with Boiler scale? Boiler scale is going to coat the inside of the pipe, right? And so due to Boiler scale, R gets smaller over time. R gets smaller over time. So if R gets smaller, what does that mean? That means that the change in pressure, right, delta P, has to go up as R to the fourth in order to account for this drop off in the radius. Delta P has to go up as R to the fourth. And if we simply assume that the energy, right, the energy is proportional, hold on a sec. Okay, so if we assume the energy is proportional to the energy consumed is proportional to delta P, which is a reasonable assumption, then we expect the energy over time to increase as R to the fourth. Why? Because R to the fourth term is decreasing. We have to compensate for that by increasing the pressure. And so what we're really looking for and expecting is for a curve to be something like this, right? Where this is energy. And again, this is all qualitative. It's not quantitative, right? Just reasoning through what should look like. This is energy, time, and it should increase exponentially as time goes on. And that would mean that the answer is D, option D. And that's the end of problem 23.